I will speak in English for this session. We'll try. My English is not the best, but I'm close to the monkey, so it's normal. I was planning to do something really deep here in this session, but I just decided before it to present it on the slides instead of technically on the servers, just to not risk to fail down again. And yeah, what we are talking about today, zero downtime Postgres upgrades. Every one of us knows that software change every year. If it's not changed, the bad people are trying to, let's say, compromise it. And these upgrades are mandatory because without them, we are risking not only systems, but also businesses. Postgres is developing really intensively, and every year they produce new software version. What that means, we should be prepared with upgrade planning really strong. And plan the upgrades year over year, so it never stops. What is the problem with this? During the upgrade, we have downtimes. Even in cloud, where all the businesses are going, it's very modern these days, we have downtimes. And downtimes can be from 20 minutes to 2 hours, and some applications could not accept this, meaning they have live customers, financial transactions, and a lot of mess can happen if you go down. If you're into the business, you know how bad it looks if your financial application is down. And yeah, traditionally we do upgrades even in the cloud using strategies that result in these scenarios. Dumping and restoring, cloning VMs, etc. And up till now, up till version 17, after each upgrade, we should also update our statistics because we know our databases needs to be aware what they contain, how many rows are in the table to produce the best execution plan. And Postgres has this luck. They do not move statistics automatically between the versions. This results in another period of time, maybe it depends on the size of the database, where our data may not be available for our customers. Now on the screen is the normal upgrade process. It differs between the architectures, between the providers, between the setup that we have, on-prem, cloud, whatever. But in general, this is what happens. The new version is once installed. The data is, the applications are stopped. The data is moved or upgraded in place. If you have new cluster, you start the new cluster, then you update your statistic, then you stop your new cluster, and it's multiple times during this process that you result in outages. And you cannot accept your applications working on top of this unstable database environment. But without data, as we already know, your application means nothing to the customer. This year, 2025, Postgres did a huge step by implementing a strategy inside the engine to move statistics together with the upgrade. Meaning, if you upgrade your instance in place, your statistics will be transferred as well. And this results in less downtime and less scenarios where your execution plans go wrong. How that what that means when you are in the cloud, you may save money. Why is important? Because when you have unoptimized plans, your CPU can go crazy, your storage can go crazy, your memory can go crazy, and if you have a bad designer that chose to auto-scale your database instance, your build can go crazy as well. So this step in the part of the statistics is really important for the new version, and I believe this is why we are stepping really hard in front of the commercial RDBMS systems. Who will win more deals? This is what it means. So for today's session, just for you to be aware, I did these slides 40 minutes before the event. So it's a little bit stressful to present without preparation, but this is how it works. Even in the business, when you're on the field, sometimes it's stressful, so you need to be prepared. And our mission for today, for this session, is to upgrade Postgres version 13, which is already outdated. It's not supported anymore. No further patches will be produced for it, to version 16 or 17. Why not 18? Because on the environment that I am working on, and most of you, version 18 is still not available. It will be maybe in the 6 months elsewhere. But nowadays, the most common versions are 16 and 17, to which we are upgrading. The goal is to do this with almost no interruption, but almost means completely invisible for the application. And that's possible, yes, even in the cloud environments. It's an option. We can design to achieve zero downtime upgrade with multiple, let's say, software configurations. Our Postgres instance from the source should be read and write, available for reads and available for writes. And lucky enough, we will have rollback scenario, something that you don't have on cloud providers, or you don't have it by their solution. Of course, I tested this on our SAP BTP platform. It succeeded. I'm not able to present it in front of you like really live, but I'll go across the slides and explain what happens in behind. And behind the scenes, there is a lot of small steps that were implemented, but we achieved finally a great result. So our source DB will be version 13, target DB will be version 17 for this. We will be using PG Bouncer, integrated into our application, or it can be even started on SAP BTP platform as an external service. So you can not directly connect to your Postgres instance, but go through the PG Bouncer, who has really nice features like pausing the transactions for 30 seconds, redirecting the traffic, and doing a lot of magic as well. So PG Bouncer also controls your sessions in a manner that they can be kept alive. It will help us to reduce the downtime. But of course, only PG Bouncer is not the case. You still will have short period of time that your database will not be available. Because we are on BTP platform, we at the hyperscale service limit your logical replication options. Usually, if you design on-prem system, you may be chose to have active and standby server, mirror the data through our application, and when it's time, just switch over to the new system. But we limit that parameter, so we do not allow you to do that for many reasons. Of course, in heavy costing plans, you have it. So to achieve the zero downtime scenario, we put one more component in place, and this is the Redis cache. What this part will be responsible for just small period of time, all the sessions to be kept in this cache and just not result in dying for the application. So whatever happens during the upgrade, during the instance that we are stopping, starting, whatever, these sessions will be kept in the Redis cache and will not be reported as closed for the application. So this application, maybe you will see a circulating window, or it happens all the time. You maybe lost the connection for the internet for a few seconds, but this doesn't cause the customers to refresh browsers or whatever. So let's go forward. This is the design that we are heading for. It's very simple. Our applications can be deployed in SAP BTP platform with many instances. What that means, you can move loads between multiple instances, and you can, let's say, achieve blue-green deployments by having this. 3 or 4 instances can act like splitting the load or just covering instance that goes down, whatever. We are not going deeply into that part because I'm DBA, not the application developer. But yeah, that's an option in our platform. We will be doing connection to the Redis cache for keeping keys for the sessions in this cache. And we will be having PG bouncer that will control where actually we are connecting, to the source DB or to the target DB. And because we are limiting the logical replication, I chose for this scenario PG loader with the flow option. What happens when you use PG loader? You can move data from your source to your target, and you can track the changes from the source and apply to the target real time. So you do one initial load, then you start it with flow option, and you trace changes that are happening here and apply it to the target database. Of course, if you do it at 8:30 in the morning, like we did today, it is going maybe to not be the best time to upgrade your instance. You will never be in sync. So you prefer to do that part in period of time that your applications are not so heavy loaded. At some point, they will go for completely equal, and yeah, this is the time where the magic actually happens. So let's go. It's easy like this to create Postgres instance in BTP environment. You create your account, you subscribe for a subscription, you choose a plan, and you just execute this command or click 2 buttons from the cockpit and you have Postgres available. You can have many versions. You can also create the same way and the Redis cache instance. And the best part of this is that you're not restricted to use only one cloud provider. You can do it on today 5 different providers. One of them is SAP itself. So you can go to Amazon, Microsoft, Azure, which I personally do not recommend, as always. And you can go to AliCloud, which is if you have China restricted data, or Google Cloud, which is still going very good. Just from experience, the most comfortable environment that I'm working with is Amazon. So just to mention here, the joke for the Microsoft is not because of their cloud is bad, it's because like a person being in Oracle for 12 years, I don't like Windows, so everything with Microsoft is a joke. It's not something that you understand maybe in the wrong way. They have good solution for Postgres. Okay. After we created our instances, let's imagine, because we cannot show it now, it's already 20 minutes past, so if I needed to do all these steps, it could take me 3 hours to upgrade. So I decided to go faster and just go through the slides. So next step, the PG Bouncer setup. You can integrate your PG Bouncer directly in your application. Let's imagine it's Java application. You create a script that starts the software locally on your virtual machine. You put your script into the manifest file, and once you run your Java application, the PG Bouncer also starts. And your configuration now will not point to the database host and port directly. It will point to the PG Bouncer, who is responsible to split the traffic at some point. This is important because you can host it separately or you can integrate it into the Java app. And if you are a developer, you should think about it. When you design your system, you need to think about scaling it up. When I built my first website, I had 2 users. 2 weeks ago, 2 weeks after, I had, let's say, 3,000 or something per minute. And it wasn't a really nice feeling, to be honest. It was down all the time. So when you design, you better think about scaling up, which our platforms allow. And you can also think about doing some magic with PG Bouncer to help you control the load. So next slide. It should be executable, yes. The script runs locally on the VM. It can be running behind the scenes, and when you integrate it into your Java runtime, it's a completely achievable scenario. This is how the configuration file looks. I'm not going deeply into this, but what's important here is that you have on your Java application PG Bouncer starting and Redis cache integrated. So your sessions may go through the Redis cache when needed. You can control on this one. And this is what we are going to do. This configuration file now points to our Postgres old instance 13. And later, we will change this to our new instance 17 by just rescheduling the application with one simple command. Okay, we said that we are going to use PG Loader. PG Loader has configurations that can be different based on different scenarios. This one is sample here. And this one do actually set concurrency, number of workers, 8 in this example. What we are migrating, do we migrate date only, or we keep other data models also migrated? It captured the create table and create index statements, meaning if you create new table during the load, it will be transferred as well. And yeah, you do not drop any table, meaning if during your load, you drop a table, it will not be replicated to your target environment, so this table will be there. But from experience, I don't know actually, maybe some people do stupid things, but from experience, when you do migrate databases, it's a really controllable window and no one touches something else in the database. Drop tables is not something that you do during the migrations. Or not something that I would do. Okay, so we first copy the main set of data once, then capture the state, and then start with a flow option, which is inside this configuration file. It's not in the screen, but this is -- flow, and that starts tracing your changes and moving them to the target database. During this period of time, your users are connected to the old instance, version 13. They see nothing regarding this migration and this data moving. And you can keep it for a long time until you are completely sure that you are ready to switch to the target. You can monitor the process per table, how many rows are still different, how many rows are on the source, how many rows are on the target. Yep. That happens with some queries. I extracted a sample here. And when you feel comfortable that your source and target database are equal, you can do something to analyze the source, to analyze the target if you're on old environment, and then think about switching to it. But when we think, we go back to the design and we want to see what happens. Currently, our load is still here on the source. PG bouncer directs its connection string to it. The target is synchronized. Any change here is also synchronized on the fly. At this second, I decide, okay, I want to go here. I want to switch. And what I do here to achieve it is reschedule my application with new configuration for the PG bouncer, or if it's hosted externally for the application, I just restage the PG bouncer itself, changing the configuration to the target database. And that's an outage. I don't like it. It's maybe 2 minutes, but it still can result in customer loss. This is why I kept one more component in my design graph, and this is the Redis instance. How it works: Redis instance can be dealing only with read requests, cached data, can be dealing with sessions data to keep the sessions data in Redis for 30 seconds before going to the database itself. And this means we can survive for 30 seconds without connection to the database, because your Redis cache will serve and will never report to the application that it's down. This session doesn't disconnect. And how Redis achieved this? We said the Java application is configured to connect to the Postgres 13 node instance, and the active session data is hosted on Redis cache. And in periods of time written, maybe some data is written to the Postgres more often, but you can configure this, how often that can happen. Yeah, the connection for Spring Boot application, this is just example, don't focus on it. I just needed to put something on the screen, otherwise it could be one line of words. But this is just example how you configure your Java application with Redis and host cached session data. And of course, the last line is our simplicity. In our platform, we do this with one command. We actually bind the application to the Redis instance very easy with one line of code. Okay, during the PG loader, the applications are still connected, as we said. The PG loader continuously syncs the data, and Redis holds the sessions. There is no downtime here. This is fully online for the customers and not yet switched over. We are still on the old instance. But what happens to the switchover? The application goes read-only for a few seconds. Why this is needed? Because we need to make sure for these few seconds our target and source and target are fully synchronized. We cannot achieve data consistency without being completely sure about this. So every single row should be on the target. Once we are ready, we update the PG browser target connection, and that can be achievable if you host it on like as external instance. This is achievable by CF command in our environment, so you can directly restage for a few seconds to the new host. And this happens with CF restage command. Okay, at this point, usually your application could restart, maybe, meaning this is the PG the PG bouncer application. So you lost the connections if you don't have the cache, but Redis keeps that data and keeps the data for the user sessions and never return back to the application, to the Java app, that this session has already died. It's died, but it's cached in the instance. So the application never recognizes this. It may not serve data, it may think a lot, it may wait, but it will never crash and you will never see 404 here. Once everything's back up, your application just connects again to the database through that cached session, and this meaning is continuing the work it's doing. Okay, this was our cutover scenario, and I'll go back to the design graph. At the moment, we are already on the target. This is like a storytelling, not like deep dive, but I adapted to the stream today. So we are now in the target database, and our application still have the Redis cache active. It hosts some data for the sessions. PG bouncers control the load and transfer it to the target database. We are now on the new version already. And at this point, someone can say, okay, it's not working for me, it's too slow. I want to be back to 13. It's still live, but I don't like it. I want to be back. If you are on a cloud environment without proper design on top, you will be also having big problems to rolling back this scenario. You will be doing restores, data movements, new deployments, some special techniques that do not guarantee any online solution. This is why we wanted to have the rollback scenario, and I'll really shortly go through it. If you want to achieve rollback, the only thing that matters is you turn this target to a source. So your new 17 version starts to act as source database. You put your 13 version back in sync, and you go through the same process once again, and you have wrote back your upgrade to the older release. And this is it, really short. It's not a deep dive, but it's a sample that you can achieve a lot more if you think about it. If you just think to utilize your cloud infrastructure in the way it is, it will be working perfectly. You will have upgraded instance, but you can have 20 minutes, 1 hour or 2 hours, sometimes really more than these outages. And these outages, the problem with them is it's not controllable by us, because we do not have control on the infrastructure behind our environments in cloud. And this is why on-prem is still alive. I personally, I'm not speaking like presenting any company here, but I personally still like to work on on-prem environments just because of the control. Also the security and etc. This is why, you know very well, the new trending cloud model is actually customer-known clouds. And most of the companies will go there really soon. And thank you very much. I will save you some time, and for myself as well, because I feel a bit tired with all this conference organization stuff, but I hope you enjoyed that session. Yeah, thank you.